So, lots of indeterminate forms. Some we've already started talking about this year, like 0 over 0 is an indeterminate form. And at 0 over 0, we typically see a hole in the graph, yeah? Some other indeterminate forms, infinity over infinity. Some other ones. 0 times infinity. What's 0 times infinity?
0.
Yeah, I don't know. Because infinity is not like a number. How about this one? Infinity to the infinity power. Does that one feel good? Zero to the 0 power. But 0 to any power is 0. Yeah, that's why we call this indeterminate. Just like 0 on top of anything is 0. Anything divided by itself is 1. So, are you guys with me? So, indeterminate forms are icky. Okay? All right. So, we've talked about indeterminate forms a little bit. Like if I look at, say, this one, I get 0 over 0. But like in that first unit, we learned that we could factor this out, right? And call this 2 times x plus 1, x minus 1. And then just cancel out those x plus 1s to figure out, well, what is this limit? And it works out to be negative 4. Everybody good? But if I tried to do that, say, with this one, what did we do for this one? It's actually a pretty good idea that we review this.
Yes. Isn't it by the exponents?
So what we would do is we would multiply by 1 over that highest exponent. We'd do that to both the top and the bottom. So that we have the limit is x goes to infinity of 3 minus 5 over x squared. And then 2 plus 3 over x squared, because we were comfortable calling both of these 0 as x goes to infinity. Okay? Yeah.
I think I either lost my notes packet or left it home. If there any extras.
Probably. Maybe. I don't. That's all your stuff for the next unit. I certainly would be happy to print one for you.
Thank you.
I'll just print the last 2 pages so that we still have that paper. As soon as we're done. It's in the back. Or it'll be in the printer right over there.
Thank you.
I was never going to find this. Okay. Everybody good? That we said anytime the limit as x goes to infinity, if you have a constant on the top and x on the bottom, you're talking about like 5 divided by a gajillion, which is going to be really darn close to 0. So the limit of a number over x is 0. So if we divide basically everything by x squared,
So it's like 3 minus 0
over 2 plus 0, which is 3/2. Everybody good? All right, what if I gave you this one?
Can you take like the ln at the top and the bottom? Or does that change?
Isn't e to the 0 just 1? Am I totally
Yeah, but when you plug that in, you get 1 minus 1 over 1 minus 1, which is 0 over 0. All right, you guys. We could do this. E to the x plus 1, e to the x minus 1. Because e to the 2x is the same thing as e to the x, the quantity squared, and then it's really not that different from what we did up top, yeah? Then what happens?
We just have e to the x plus 1, so we get 1.
Then I can cancel those out, and now I have the limit as x approaches 0 of e to the x plus 1, which is 2. The e to the x becomes a 1, and then the 1 stays a 1, and then the, you know. Do you guys like my technical wording here?
Yeah.
How are we feeling? Still good? All right. And then we get to this beautiful question. You guys, there's a frost advisory. I don't know if you guys are all getting the same frost advisory, but I'm hearing like 15 phones going at once. Am I the only one that gets the weather advisories as a notification? It was beautiful.
It was beautiful until I stepped outside. It was cold.
You guys, will factoring help me here?
No, because it's actually no, because it's a minus 1 and not a plus.
Okay, you guys. So here's where we're at.
Actually, wait, it's the same thing.
It's not the same thing because now I don't have a denominator that I can factor to cancel. Okay, is everybody good? So this would be a perfect example of when we could use L'Hopital's rule that says instead of like rewriting it, what we can do is just take the derivative of the top and the derivative of the bottom and take that limit instead. So you guys remember doing L'Hopital's rule last year, yes?
I think so.
love it.
Okay. Here's what Ms. Meister will expect to see in order for you to do L'Hopital's rule. If I plug in 0 right now, what do I have on the top?
0 over 0.
0. What do I have on the bottom? As x goes to 0, I would have 0. Yeah? I need to see that. Or I need to see infinity over infinity. Reasonable?
Yeah.
All right, what's the derivative of e to the 2x minus 1?
2e to the 2x.
What's the derivative of x?
1.
You guys, what is the limit as x approaches 0?
2.
2e to the 0 over 1, which is 2. How are we feeling? Okay. On this test, you will be allowed to use L'Hopital's rule on any limit question I give you. On the final, if it gets approved, I sent it today to get approved, to which the lead instructor, I'm certain, is going, high school teachers prep way too far in advance. But on the final, there are some where you are not allowed to use L'Hopital's rule. So you still, it'll say it.
Okay.
And then there's the ones where you can. So, can we talk some more about L'Hopital's rule? All right, let's look at these first two questions, you guys. Some things that are worth remembering. As x approaches infinity, what happens to the natural log of x?
What? Wait, what?
Doesn't it get higher?
Isn't the ln of x? What is the natural log of x?
Let's real quick go over the graph of y equals ln of x.
I need a quick refresh on that.
All logarithmic functions have the same general form.
It increases.
Oh.
They are the inverse of the exponential functions.
Oh, okay.
You guys, this point right here is none.
Is 0?
1, 0.
Yeah, 1.
Because the natural log of 1 is saying e to what power equals 1. That answer is 0. If this is e, This is the point E1. Everybody good? Okay. So, as x is approaching infinity, what is going on with this particular function?
It's closer to
I think it's getting smaller.
zero. There's an asymptote here.
But what's going on with, is it an asymptote?
Well, I can't tell by the way you drew it.
It's still continually increasing, okay? What about what happens to x as x approaches infinity? Infinity. Technically, this is negative infinity. No, that's positive infinity still. Ignore me. Ignore me. I'm thinking as we approach 0. Okay. What does that mean? This means we can use L'Hopital.
I'm sorry, I'm just a little confused. So when we see that ln of x
As x goes to infinity.
as x goes to infinity, the natural log of x will go to infinity.
Mm-hmm.
Same with negative infinity. If x is approaching negative infinity, the natural log of x will be approaching negative infinity.
No, as x approaches negative infinity,
It's gonna go.
it's undefined. As x approaches 0, it goes down to negative infinity.
Okay. Thank you. I just wasn't remembering what exactly the ln meant in this situation, but it makes sense.
Are we good? Yes or no? Now what do I have when I do my substitution? 0 over 1, which is, so we know the answer is 0. Look at this beauty of a question.
Can we have 0 as an answer?
Yeah, why not?
I don't know. Never mind.
Okay. The limit as x approaches negative infinity of x squared over e to the negative x.
Positive infinity.
The top is positive infinity.
And
E to the negative x as x approaches negative infinity is e to the positive infinity power.
which is infinity.
So, we've shown, you're not convinced of that at all, are you?
No, I'm just not here. You're good.
Negative times positive.
If I took a negative infinity in for x, these would become positive infinity. E to the infinity looks like this, or e to the x looks like this, yeah? So as x is going this way, the y's are going up to positive infinity. Cool?
If one of the infinities was like a negative, like on the top or the bottom, would it make any difference as to being able to do L'Hopital's?
Nope. Yeah.
If like the top is infinity, would like just the top, if it was like infinity over like 2?
That's infinity. It's only indeterminate if it's infinity over infinity. Good? All right. So what should we do? Take the derivative or derivative of the top and the bottom. I get 2x over negative e to the negative x. Is that right?
That's still good.
This is, in fact, still infinity over infinity. So guess what? We just go it again.
Would it be negative infinity?
Now I have a 2 on top. So now I have 2 over infinity, which is So I just took the derivative again. So sometimes we have to do L'Hopital's rule more than once. You guys ready for the next set? Oh, what a beautiful question. You guys, look how beautiful this is. It's something, isn't it? Yes. Yeah. I added the negative because I was the worst. So I didn't take you guys through the proof of L'Hopital's rule because I don't think you want it. But it basically, if you knew the proof, you would see that infinity over infinity and negative infinity over negative infinity, they equal, they're not the same thing, but with respect to L'Hopital's rule, they use the same reasoning that you can still use L'Hopital's rule.
So what infinity over negative infinity or negative over negative?
Oh, you're saying this should be negative 2? That's fine. It probably should, because 2 times negative infinity would be negative. Now we good?
But the bottom, wait. I guess that would be.
E to any power is positive, yeah? And then the negative would attach to it. Okay. Let's talk about this beauty. You guys, what does the graph e to the negative x, what would that look like? Kind of goes down this way, yeah? Everybody good? So, what is the limit as x goes to infinity? All right, what about for square root of x? As x goes to infinity, what's happening? Is this a L'Hopital form?
Yeah.
Yes.
Yeah.
What are the L'Hopital's forms?
0 times infinity.
No, it is an indeterminate form. L'Hopital's forms have to be 0 over 0 or infinity over infinity. Those are the only times that...
So it's 0
So, no,
or indeterminate.
it's still indeterminate. So, when this happens, we are going to use algebra to rewrite it. Seamus, what is an idea you have to rewrite this?
Root x over e to the x.
Is there any reason? Isn't that what e to the x, or that isn't that what a negative exponent does? Is it moves stuff to the bottom?
Yeah.
So we could call this the square root of x over e to the x. And if I write it this way, I have, well, we said the square root of x is infinity, and it takes this graph and it flips it back this way. So what is the limit of e to the x as x goes to infinity? Infinity. Now I have a L'Hopital's form. Everybody good? All right, so we take the limit. X goes to infinity. Oh, man. The derivative of the square root of x is 1 over 2 square root x, yeah? Are we comfortable with that? And the derivative of e to the x is it e to the x?
Just e to the x, 'cause it's times 1.
Which is equivalent to 1 over 2 e to the x square root of x, yeah? Those are the same thing. So, now we have 1 over infinity, yeah? Which is? We're done. Are we feeling good? Let's go to the one next to it. Okay, I really need to order you guys some Nerf balls. What do you guys think about this one?
It's just gonna be,
I'm numb.
does this even apply here? Like,
No.
What is the form it's in right now?
it's not an infinity over
Plus
infinity.
0 to the.
So 1 plus 0 to the infinity, are you guys with me that that's 1 plus some change to the infinity power?
So it's infinity.
Nope.
Oh, it's just 1.
Nope.
Indeterminate.
Nope. Well, this currently is an indeterminate form.
It would be 1.
It is not 1. The answer to this will not be 1. Does anybody know the answer to this just because you know it? Anyone?
Pi. I don't know. This thing is not that we're supposed to just know. I don't know. Is it E?
It is E. This is the definition of E.
Oh, okay.
This is what E is. This is the definition
Oh my
of
gosh,
E.
Okay, so
However, would you guys like to see the proof that this is equal to E?
no, I'm okay. I believe you.
Would you guys like to see how to find this limit when I give it something similar but not the same on the test?
Yes.
So let's talk about it, okay? We will get E as our final answer. We will absolutely get E as our final answer. But we should probably understand why that works. Especially when I give you one like the next one. So, all right. So, do you guys remember when I asked you to take the derivative of something like this, that what we ended up doing was taking the natural log of both sides of the equal sign to get that exponent not be a variable. Like to not have the variable be in the exponent. You guys remember that we did this? Okay. Whenever, I'm not saying always should you take the natural log of both sides, but boy does it make it a little bit easier. So, that being said, in order to take the natural log of both sides, we probably need an equal sign. So I'm going to go ahead and set this equal to y, and my final answer will be the value for y. Everybody good? Okay. And then the next thing I'm going to do is take the natural log of both sides. When I do that, I will have, on the left, I will have the limit as x goes to infinity of x times the natural log of 1 plus 1 over x equals the natural log of y. I'll let you guys process that for a second. How are we feeling? All right. Now, if I take this limit right now, what do I have? The x would be infinity. This would be the natural log of
Basically 1.
1. What is the natural log of 1?
Something positive.
0.
So we would have.
Is everybody comfortable with this? Okay. Okay.
Still indeterminate.
But anytime we have 0 times infinity or vice versa, okay, you can rewrite it. So we are going to rewrite it. We are going to call this left-hand side the limit as x approaches infinity of the natural log of 1 plus 1 over x over 1 over x.
It's still over 0 though, right?
Now what do I have? 0 over 0. Is this, so this, in the green line, infinity times 0 is not a L'Hopital's form. This one is a L'Hopital's form. You see, so even though this looks a lot more complicated,
No, this is gonna be a quotient.
no, it's not, because remember for L'Hopital's, we take the derivative of the top and then we take the derivative of the bottom separately. So this becomes the limit as x approaches infinity. You guys, what is the derivative of the natural log of 1 plus 1 over x? So let's start with the first part of it. 1 over 1 plus 1 over x times the derivative of 1 plus 1 over x.
Negative x, so -2.
Negative 1 over x squared. Perfect. It's the same idea. Okay, what are we going to do to the bottom? Take the derivative of 1 over x. What is the derivative of 1 over x?
Negative.
Negative 1 over x squared. And now those things cancel out.
What are we doing with this ln of y? Are we allowed to just, do we need to?
I'd like you to have deep breath and some patience. So what do we got for this limit now, y'all? What is my limit?
Just one.
1 over 1 plus 0,
We all-
right? So here we just ended up with 1 equals the ln of y. What are we trying to find right now? Y. Originally, we want to find the value of the limit. The value of the limit is equal to y. Okay. You guys. Are you guys with me that natural log of y is equivalent to saying the log base e of y? And if I rewrote this in exponential form, e to the 1 equals y. And we've just shown that why that is the formal definition of e. Because that's where we end up. You guys, only 2 more examples. You guys ready to do this one? What's the answer to this one? Pi?
I'm just kidding, I don't know.
I want to say it's e squared, but I can't remember off the top of my head. But we got to work it. And guys, you will get one of these on the
0 from the root.
test.
Could
Huh?
you just like memorize it?
You don't know what my inner function is going to be.
Oh.
You will have something to the x.
Oh, that's what you're saying.
That's what I'm saying. You will have something to the x. But I promise, it will start feeling better.
Okay. I believe.
So, and again, when we have something to the x and we don't know what to do, certainly making it equal to y so that you can take the natural log of both sides, I think makes things a little bit easier. Okay, so now I have the limit as x approaches 0 from the right of of x times the natural log of sine x equals the natural log of y. Everybody good? Now what? Can we do L'Hopital's? Or can we just take the limit?
Well, why? It would be 0.
Sine of x is 1. I agree. So are you with me that like ln of sine x as x approaches 0 is the natural log of sine of 0?
Can you say that again?
If I plug 0 in right now, I'm taking the sine of 0, right?
Oh, it's 0.
Which is the natural log of 0. If we go back to our natural log function, at x equals 0, what's happening?
Decrease.
It's decreasing all the way down to negative infinity. So no, we can't just do this as this is. And this is a 0. I don't know why I wrote a 1.
And we're able to say negative infinity because as the function of sine is approaching 0.
Natural log is approaching
That's what it is. Okay, cool.
the natural. So the sine of x is approaching 0, which means natural log is approaching
Negative
infinity. Yeah.
Cool.
Okay. So what do you guys want to do?
Now we have to change the setup because of the L'Hopital.
Take our derivative. What's the derivative of the natural log of sine x?
Wait, how is this? How are we able to take the derivative of this? Because it's
Because now we have
1 divided
negative infinity over infinity.
1 divided by 0. Oh, because it's coming from the right.
Well, it doesn't matter where it's coming from. No matter what, a constant over 0 is infinity. It's either infinity or negative infinity.
Oh, yes. Okay.
Are we good? All right, so what's the derivative of the natural log of sine x? It would be 1 over sine x times cosine x over negative 1 over x squared. Yeah? You guys, would you be okay if I rewrote this as cotangent x? Because it's essentially cosine over sine. Now what do we have?
0 to 0.
The bottom would be infinity, right? Because you'd have 1 over 0.
Why is 1 over 0
What is that
infinity?
infinity?
Yeah, why is 1 over 0 infinity?
Well, it's 1 over some really, really tiny number.
Oh, positive number. So it'd be,
Oh,
wouldn't it be negative infinity?
Yeah, fine. Negative infinity. The top,
You're good. It's like this.
because of this negative. It is undefined. Cotangent, let's see, cotangent's cosine over sine. So is that it'd be positive over, yeah, I think it'd be positive infinity, yeah. That's a bummer. So you have two options to go from here. We could do L'Hopital's again. But I'm assuming you guys don't want to. Does anybody remember the derivative of cotangent?
Cosecant cotangent? Negative.
What is the derivative of tangent?
Secant squared x.
Secant squared x. Would you guys like to refine?
negative cosecant.
It would be negative cosecant squared. Okay.
Oh, I know.
Wait.
Yeah.
What would be negative cosecant squared? Oh, the
Everything for the like sine and cosine are just opposites of each other. It's the same idea but opposite. And that's true for all of them. So like if the derivative of tangent is secant squared, the derivative of cotangent, and then tangent is cosecant squared, but it's negative. It's all the ones with a c are negative. Okay, you guys. Would you like my next piece of advice?
Yes.
Okay. In the morning class, we took the derivative from here, and then we took the derivative again and again and again, and we just kept having cotangents and cosecants, which all equal infinity at x equals 0. Instead, I'm going to choose to do this. Isn't cotangent on top a tangent on the bottom?
Oh, yeah, oh.
Is everybody good? And then the negative 1 over x squared, I'm going to flip back up to the top.
Okay, so negative x squared over.
And now when I take my derivative, I have 0 on top. What's the tangent of 0? 0. I know, this feels icky. I promise we're almost done. Is this a L'Hopital's form?
Yes.
Okay. What is the derivative of negative x squared?
Negative 2x.
Derivative of tangent. If I plug in here,
0.
0 on top. Secant squared of 0. To find that, we might want to think of what is cosine of 0. 1. So secant squared is the reciprocal of that 1. 1.
So this is 0.
But these are, remember that 0 is equal to the natural log of y.
Oh my god.
So e to the 0 is equal to y.
E to the 0 equals y.
Isn't that not real?
Y equals
Oh wait, that's
1.
1. Okay, I understand that all.
We only got one more. It's not as bad. I promise. You guys, my original plan was to split this up. Okay?
And then we took forever on the test.
And then, well, we had time to split this up and me still teach some of this to you yesterday, but I saw the looks on your faces. And I decided asking you to do any more work would have made you punch me in the nose. You guys, if I plug the 1 in right now, I would have infinity minus infinity. Because it would be 1 over 0 minus 1 over 0.
Well,
No, because you can't have a 0 in the bottom. Anything over 0, a number over 0.
I'm saying the minus is better than negative.
Oh, but we don't. But these are infinities. They're not numbers, so we can't just assume they're the same. In the same way, we can't say infinity over infinity is equal to 1. Nope. You guys, this one is. I promise you, this one is not bad. Okay. Now, L'Hopital's rule requires I have one thing over one thing. So what we need to do is take these two fractions and turn them into one fraction by.
Finding a common denominator.
That's what
Okay, so we're going to take this first fraction. We're going to multiply it by x minus 1 over x minus 1. We're going to take this second fraction. We're going to multiply it by ln of x over ln of x. Once we do this, we will be taking the limit as x approaches 1 from the right of x minus 1 minus the natural log of x over the natural log of x times the quantity x minus 1.
Let's go last year seniors. I want to know who it is.
I'll look at it. give me 3 minutes. Okay, you guys, this is now of the form 0 over 0. Let's take that derivative. We'll finish this on Monday.